Hello students, in this video we are going to solve 9th class mathematics first chapter real numbers exercise 1.1. Main points: natural numbers is denoted by capital N. It contains the counting numbers 1, 2 and 3 up to infinity. The whole number set is denoted by W, capital W, and it contains the numbers 0, 1, 2, 3 and so on. Next is integers set is denoted by capital Z. It contains 0 and the negative numbers minus 1, minus 2, minus 3 up to negative infinity, and the positive numbers 1, 2, 3 up to positive infinity. And next one, a rational number set is denoted by capital Q. It contains all the numbers which can be written in the form of P by Q, where P and Q are integers and Q cannot be equal to 0. These are the number sets we have learned in the previous classes. First problem, A bit. Write any three rational numbers. Example, we know that the rational numbers are in the form of P by Q, where P and Q are integers. For example, 2 by 3 is a rational number, 5 by 4 is also a rational number. We can take negative numbers, minus 7 by 2 is also a rational number. We can give so many examples. B bit. Explain rational numbers in your own words. We can give the definition of a rational number like this. A rational number is in the form of P by Q where P and Q are integers and Q is not equal to 0. We can give the examples: 3 by 2, 5 by 3, minus 1 by 2, etc. Next problem, give one example each to the following statements. First one, a number which is rational but not an integer. Rational number but not an integer. We can give examples which are in the form of P by Q. Example, 2 by 3 is a rational number but not an integer. 1 by 2, minus 5 by 3. Like this, we can give any number which is in the form of P by Q, where Q not equal to 0 and Q not equal to 1. If the denominator is equal to 1, it will become an integer. So if the denominator is not equal to 1 and not equal to 0, then it may not be equal to an integer. It is only rational number. Now the second one is a whole number which is not a natural number. There is one and only one number, whole number 0, which is not in the natural number set. And third question, an integer which is not a whole number. In the integer set, we know that negative numbers and 0 and the positive numbers are there. 0 and the positive numbers are in whole numbers, and the negative numbers are not a whole numbers. So we can give all the negative numbers as example. That means -1, -2, -3 and so on. All the negative numbers are integers but not whole numbers. Fourth one, a number which is natural number, whole number, integer and rational number. So everything is asking natural number, whole number, integer and rational number. So we can give example as natural number, because every natural number is a whole number and integer and a rational number. So we can give example as all the natural numbers 1, 2, 3, 4 and so on. All the natural numbers are whole numbers and all the natural numbers are integers and all the natural numbers are rational numbers, because natural numbers can be written in the form of p by q. That means we can take the denominator as 1, 1 by 1, 2 by 1, 3 by 1, 4 by 1. So natural number is also a rational number. Next one, a number which is an integer but not a natural number. Integer but not a natural number, that means we have to subtract natural numbers from the integers. That remain the negative numbers and the 0 and the negative numbers 0, -1, -2, -3 etc. These are the integers but not natural numbers. Next problem, find 5 rational numbers between 1 and 2. Let us solve this problem. In order to write 5 rational numbers between 1 and 2, express 1 and 2 as rational numbers. That means in the form of p by q, with the denominator equal to 6. Denominator 6, because we have to write 5 rational numbers between them. So take denominator as 5 plus 1 is equal to 6. So we can express 1 as in the form of 1 by 1 as a rational number. 1 by 1 is equal to 1. Now the denominator should be equal to 6. So multiply the denominator with 6 and the numerator 1 with 6. We will get 6 by 6. So 6 by 6 is equal to 1, we know. And express 2 as 2 by 1. So make denominator as 6. We have to multiply it with 6. And multiply the numerator also with 6, we get 12 by 6. So 1 is expressed as 6 by 6 and 2 is expressed as 12 by 6. In between these two rational numbers, we know that there are 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6. So the rational numbers between 6 by 6 and 12 by 6 are 1 is written as 6 by 6, it is less than 7 by 6, and it is less than 8 by 6, and it is less than 9 by 6, and it is less than 10 by 6, it is less than 11 by 6, and it is less than 12 by 6. 12 by 6 is nothing but equal to 2. So in between 1 and 2 there are the rational numbers 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6. We have written 1, 2, 3, 4, 5 rational numbers between 1 and 2. We can express them in the simple form. We can convert it. 8 by 6 can be again converted by cancelling the numbers. 2 4 is 8, 2 3 is 6. It can be expressed as 4 by 3. We can cancel the 9 by 6 also in 3 table. 3 3 is 9, 3 2 is 6, and 10 by 6 can be cancelled in the 2 table. 2 5 is 10, 2 3 is 6. So in the simple form, the required rational numbers between 1 and 2 are 7 by 6, 4 by 3, 3 by 2, 5 by 3, 11 by 6. Not only these, there are infinite number of rational numbers between 1 and 2. We can give the answer in so many ways. Next problem. Insert 3 rational numbers between 3 by 5 and 2 by 3. Let us solve this problem. In order to insert any rational number between 3 by 5 and 2 by 3, we have to convert them into the like fractions. Convert 3 by 5 and 2 by 3 into like fractions. How can we convert them into like fractions? By taking the LCM of their denominators. The LCM of 5 and 3 is 15. So express 3 by 5 with the denominators equal to 15. So to make the denominator 5 equal to 15, multiply it with 3. So multiply both the numerator and denominator with 3. We will get 9 by 15. And also 2 by 3 can be expressed as, to make the denominator 3 equal to 15, multiply it with 5 and also multiply the numerator with 5. We will get 10 by 15. Now observe 9 by 15 and 10 by 15. Between 9 and 10 we cannot insert any number. So take another like fraction by multiplying both the numerator and denominator with the same number. By multiplying 15 with 2, we will get 15 to the 30 and 9 to the 18. 18 by 30 is another equivalent fraction. And also multiply 15 with 2 and 10 with 2, we get 10 to the 20 by 30. Observe these two numbers. Between 18 and 20, we can insert only one number, 19. But we require three numbers. Take another equivalent fraction. By multiplying 15 with 3, we get 15 3 is 45 and 9 3 is 27. Here also 15 3 is 45, 10 3 is 30. Observe 27 and 30. Between 27 and 30 there are two numbers, 28 and 29. But we require three numbers. Take another equivalent fraction. By multiplying 15 with 4, 15 4 is 60 and 9 4 is 36. And here also 15 4 is 60, 10 4 is 40. Observe these numbers. Between 36 and 40 we can insert three numbers, 37, 38 and 39. So these are the required rational numbers, required form of rational numbers. Now we can take 3 by 5 is equal to 36 by 60, and which is less than 37 by 60, and that is less than 38 by 60, and it is less than 39 by 60, and it is less than 40 by 60. 40 by 60 is nothing but 2 by 3. So we have inserted these three rational numbers between 3 by 5 and 2 by 3. This is the answer. Next problem. Represent 8 by 5 and minus 8 by 5 on the number line. Let us solve this problem. We know that 8 by 5 is equal to, in the decimal form, if we divide 8 with 5, we can get 5 ones are 5 and 3 is the remainder. If we put decimal point, it becomes 30. 5 6 is 30. 8 by 5 is equal to 1.6, and minus 8 by 5 is equal to minus 1.6. So 1.6 lies between 1 and 2, and minus 1.6 lies between minus 2 and minus 1. So step 1, draw a number line representing the numbers from minus 2, minus 1, 0, 1 and 2. With equal distances we have to draw them. This is minus 2 and this is minus 1, and this is 0, this is 1 and this is 2. In step 2, we have to divide each unit into 5 equal parts, because in 8 by 5 the denominator is the 5, so we have to make each unit into 5 equal parts. Divide each unit into 5 equal parts. In order to make each unit into 5 equal parts, put 4 lines in equal distance between each unit. So 1, 2, 3, 4, 5. We have divided each unit into 5 equal parts. Now each unit is equal to 1/5 part. So now starting from 0, this is 1/5 and this is 2/5 and this is 3/5 and this is 4/5 and 1 is nothing but 5/5 and next 6/5, this is 7/5, this is 8/5 and this is 9/5. 2 is nothing but 10/5. In the left side of 0, this is -1/5 and this is -2/5 and this is -3/5, this is -4/5, -1 is nothing but -5/5 and this is -6/5, this is -7/5, this is -8/5 and this is -9/5 and -2 is equal to -10/5. Now here we have to represent 8/5 and -8/5. Here this one is the 8/5 and this one is the -8/5. We have represented both 8/5 and -8/5 on the number line. This is the answer. Next problem. Express the following rational numbers in decimal form. First bit, 242 divided by 1000. In the previous classes we have learned that any rational number with the denominator equal to the 10 or 100 or 1000, that means multiple of 10 power n, can easily convert it into decimal form. So here in the denominator 1000 is there, we can write it as 0.242, because if we divide with 1000, the decimal point comes after 3 digits starting from right side. Next bit, 354 by 500. We can write it as 354 by 500. This convert this denominator into the multiple of 10 power n, that means it convert it into 1000 by multiplying with 2 both the numerator and denominator. We get 2 4s are 8, 2 5s are 10, 2 3s are 6 plus 1 7, 708 by 1000. Now we can convert it into decimal form easily. It becomes 0.708. This is the answer. Next one, 2 by 5. Here 2 by 5 can be written as 2 by 5 can be converted into 10 by multiplying with 2. Also multiply the numerator with 2. We get 4 by 10. So we get 0.4 because 10 contains 1 0. We put decimal point after one place. Next one, 115 by 4. 115 by 4. We cannot make 4 as 10. We can make 4 into 100 by multiplying with 25. 115 by 4, multiply the 4 with 25, you get 100. Also multiply the numerator with 25. You get 25 5 ja 125, 25 1 ja 25 plus 12, 37, 25 1 ja 25 plus 3, 28 by 100. Since 100 contains 2 zeros, put the decimal point after 2 digits starting from right side. It will become 28.75. This is the answer. Bit 2 by 3. Here the denominator 3 cannot be expressed as a multiple of 10 or 100 or 1000. So we have to divide the numerator directly with the denominator to get the decimal form. So divide 2 by 3. 3 zeros are 0. 2 minus 0 is 2 only. Now take a decimal point. We put 0. Becomes 20. 3 6 are 18. Again we get remainder 2. And again we put 0 every time. Now it becomes 20. Now again take 3 6 are 18. Now again we are getting the remainder 2. So the digit 6 is repeating. Now 2 by 3 can be written as 0.666. So we put a bar on the 6 to denote it is repeating a repeating digit. Now second bit, minus 25 by 36. Divide 25 in the 36 table. 36 0 is 0. 25 minus 0 is 25. Put a decimal point. It will become 250. And take 36 6 ja. 36 6 ja is 216. Now you will get 4. 4 minus 1 is 334. And put a 0, it becomes 340. Now we can take 36 9 ja. 36 9 ja is 324. So 10 minus 4 is 6 and 3 minus 2 is 1. We are getting 16. Put a 0, it becomes 160. Now we can take 36 4 ja. 36 4 ja is 144. And here we are getting 10 minus 4 is 6. 5 minus 4 is 1. And again we are getting 16. It will become 160. So again take 36 4 ja. 144. Again you will get the 16 as a remainder. From this onwards the digit 4 is repeating. So we can write minus 25 by 36 as minus 0.694 only repeating. So we put bar on 4. Next bit 22 by 7. Divide 22 in the 7 table. 7 3 is 21. Remainder is 1. Take decimal point, it will become 10. 7 1 is 7. 10 minus 7 is 3. Again put 0, it becomes 30. 7 4 is 28. And we get the remainder 2 and put 0, it becomes 20. 7 2 is 14 and the remainder is 6. Put 0, it becomes 60. 7 8 is 56. So remainder is 4. Put 0, it becomes 40. 7 5 is 35 and the remainder is 5. Again put 0, it becomes 50. 7 7 is 49. The remainder is 1. Put 0, it becomes 10. 7 1 is 7. We are getting the remainder 3. From this onwards the digits again repeats. After 1 you get 4 2 8 5 7 like that. So these digits are repeating from starting from 1 to 7. These are repeating. So we can write 22 by 7 is equal to 3.142857 bar. And the next bit 11 by 9. Divide 11 in the 9 table. 9 1 is 9. 11 minus 9 is 2. Put a decimal, it becomes 20. 9 2 is 18. You get the remainder 2. Put 0, it becomes again 20. 9 2 is 18 and again you get remainder 2. That means the digit 2 is repeating. So we can write 11 by 9 equal to 1.2 bar because 2 is repeating in digit. Next problem. Express each of the following decimals in p by q form where q not equal to 0 and p comma q are integers. First one 0.36. Let us solve this one. 0.36 can be converted into p by q form by removing the decimal. It will become 36 and after the decimal point 2 digits are there, so we have to divide it with 100 because 100 contains 2 zeros. Now further we can simplify by cancelling the numbers. 136 can be cancelled in the 4 table. 425 is 100 and 4 9 is 36. So it is equal to 9 by 25. Next bit 15.4. 15.4 is equal to 154 divided by, here after the decimal point 1 digit is there, so we have to divide it with 10 because 10 is containing 1 0. So now cancel these two numbers in the 2 table. 2 5 is 10, 2 7 is 14. We get one remainder, it becomes 14. 2 7 is 14. This is equal to 77 by 5. Next bit 10.25. 10.25 is equal to, remove the decimal, it will become 1025 divided by, after the decimal 2 digits are there, so we divide it with 100. Now both the numbers can be cancelled in the 25 table. 25 4 ja 100, 25 4 ja 100, 102 minus 100 is 2, becomes 25, 25 1 ja 25. So this is equal to 41 by 4. Next one, 3.25. 3.25 can be written as 325 by 100, because after decimal 2 digits are there, so we divide it with 100 to remove the decimal point. Now cancel these two numbers in the 25 table. 25 4 ja 100, here 32 is there, 25 1 ja 25, 32 minus 25 becomes 7, becomes 75, 25 3 ja 75. So this is equal to 13 by 4. Next problem, express each of the following decimals in P by Q form. First bit 0.5 bar. In the previous class we have learnt this type of problems. Let us solve this problem. Let x is equal to 0.5 bar, that means 0.55 and so on. Call it as equation 1, and here after decimal one digit is repeating, so multiply equation 1 by 10. If the one digit is repeating, we multiply it with 10. If two digits repeat, we multiply with 100. Three digits repeats, we multiply with 1000. So we are multiplying with 10. We get 10x is equal to, by multiplying with 10, the decimal point moves one step right side, so it becomes 5.555 and so on. Call it as equation 2. Now subtract equation 1 from equation 2. Equation 2 is 10x is equal to 5.55 and so on, and equation 1 is x is equal to 0.55 and so on. Now by subtracting here, the decimal part will be cancelled. 10x minus x is equal to 9x, 5 minus 0 is 5, 9x is equal to 5. So 9x is equal to 5 means x is equal to 5 by 9. This is the answer. Next bit 3.8 bar. Let us solve this problem. Let x is equal to 3.888 and so on, because 8 is repeating. So here one digit is repeating, multiply the equation, call it as equation 1 with 10, multiply equation 1 by 10, we get 10x is equal to, decimal point moves one step right side, 38.888 and so on. Call it as equation 2. Now subtract 1 from 2. So write equation 2, 10x is equal to 38.888 8 8 8 and write equation 1. X is equal to 3.888 and so on. Now subtract it. The decimal part will be cancelled. We get 9x is equal to 38 minus 3 is 35. So 9x is equal to 35 and x is equal to 35 by 9. This is the answer. And next bit 0.36 bar. Let us solve this one. Let x is equal to 0.3636 and so on. Call it as equation 1. Here 2 digits are repeating, so multiply equation 1 by 100. We get 100x is equal to, the decimal point moves two digits right side by multiplying with 100, so it becomes 36.3636 and so on. Call it as equation 2. So subtract one from 2. So 100x is equal to 36.3636 and so on, and x is equal to 0.3636 and so on. And by subtracting, the decimal part will be cancelled. 100x minus x is 99x is equal to 36. Now x is equal to 36 by 99. We can further cancel it in the 9 table. 9 4s are 36, 9 11s are 99. So x is equal to 4 by 11. This is the answer. Next bit 3.127 bar. Let us solve this one. Let x is equal to 3.1277 and so on. Here after the decimal 2 digits are not repeating, only 1 digit is repeating. So first of all, take the non-repeating digits to the left side. Here 2 digits are non-repeating. By multiplying with 100, we can move the non-repeating digits to the left side. So call it as equation 1. Multiply equation 1 by 100. We get 100x is equal to, decimal point moves 2 steps right side, 312.777 and so on. Call it as equation 2. Now again multiply equation 2 with 10. The decimal point moves 1 step right side. Multiply equation 2 by 10. We get 100 into 10 becomes 1000x is equal to, here by multiplying with 10 it moves 1 step right side, 3127.777 and so on. Call it as equation 3. Now subtract equation 2 from equation 3. Subtract equation 2 from 3. 1000x is equal to 3127.77 and equation 2 is 100x is equal to 312.777 and so on. Now the decimal part will be cancelled. 7 minus 2 is 5, 2 minus 1 is 1, and the 31 minus 3 is 28. Here 1000x minus 100x is 900x. Now x is equal to 2815 by 900. We can cancel both the numbers in the 5 table. 5 1 ja 5, 4 is the remainder, it becomes 40, 5 8 ja 40, 5 0 ja 0. Here 5 5 ja 25, 3 is the remainder 31, 5 6 ja 30 and 1 is the remainder 15, 5 3 ja 15. Now the answer is 563 by 180. Next problem. Without actually dividing, find which of the following are terminating decimals. Here 3 by 25, 11 by 18, 13 by 20, 41 by 42 are given. We have to find whether they are terminating or non-terminating without dividing them. So there is a clue that a rational number is terminating decimal only when the prime factors of its denominator contains 2, 5 only. So we have to find the prime factors of the denominators to say whether they are terminating or non-terminating. So let us solve this one. Here the denominator is 25. 25 can be written as 5 5 is 25. So the denominator's prime factors are containing only 5. So by this clue we can say that it is containing only 5. He is saying that if the denominator contains the prime factors only 2, 5. So 2 is not there, but 5 is only 5 only there. So we can say that 3 by 25 is a terminating decimal. Terminating decimal. So we can say that yes. So here the denominator is 18. We can write 18 as 3 6 is 18 and further 6 can be written as 3 2 is 6. So we can write 18 as 3 into 3 into 2. Here the prime factors are 3 and 2. As per the clue, the prime factors are different from 2 and 5. 2 is there, but another prime factor 3 is coming here. So it is not a terminating decimal. So 11 by 18 is a non-terminating decimal. So we say that it is no, it is not terminating. Now in this one, 13 by 20, take the prime factors of 20. We know that 5 4s are 20, and further 4 can be written as 2 into 2. So 2 into 2, 4, 4 5 are 20. It is containing the prime factors 2, 5 only. So 13 by 20 is a terminating decimal. So we can say that it is yes. Now here the denominator is 42. 42 can be written as 21 2s are 42. 2 21s are 42, and 21 can be written as 3 7s are 21. So it is containing the prime factors other than 2 and 5. So 3 and 7 are the other prime factors it is containing. So it is, as per the clue, it is non-terminating. So 41 by 42 is a non-terminating decimal. So we can say it is no. In this way we can say a rational number is terminating or non-terminating by knowing the prime factors of its denominator. Don't forget to like and subscribe our channel. Press the bell icon. You will get further notifications. Thank you.